Alright, today we'll be talking about rational expressions and what exactly they are. Rational expressions are just when you take one, could be polynomial and divided by another polynomial, or monomial divided by non-monomial. It's totally up to you. But in essence, what you need to be able to do by the end of this lesson is you need to be able to find the simplest form, which is no common factors at all. Okay, so we're going to start with simple monomials, then we'll graduate up to the other ones and just work that way. All right, now what you do need for this is you need to know your factoring. Okay, whether it be simple factoring or factoring by the AC method, or difference of perfect squares or perfect square trinomials or greatest common factor, you need to know your factoring. So make sure you find a document called the factoring flowchart. Okay, so the factoring flowchart will help you immensely during this. Okay. Alright, so let's take a look at this first one. Alright, now this one's pretty much already factored. You got 15, you got x squared, you got y over 50, x to the third, y to the third. I like to think of this as simplifying fractions. So in other words, if you know how to simplify this, let's say 9 over 27, and that becomes 1/3. Well, how do you know it becomes 1/3? Well, what you do is you find the factors of 9, and in common, it has 9 in common with each one. 9 goes into 9 once, and it goes into 27 3 times. So that leaves us with our 1/3. That's the same thing we're doing, except we're going to be looking explicitly at the terms in terms of x and stuff. And then we're going to look at some little tricks that you need to know to really make your job easier. Okay, so first off, if I look at 15 and 50, well, shoot, they both share a 5 in common. So that is left over with a 3 and a 10. Now I can't break it down any further, so that's definitely going to be a part of my answer. Okay, so that's pretty simple. Now the x squared and the x cubed, obviously these ones are going to simplify out, and I'm left with just one x down on the bottom. Okay, so I just put the x down there. Okay, all right, and then the y up top and the y cubed on the bottom. Okay, there is one y up here. There's actually 3 y's down here. So if I simplify those to just ones, okay, I'm just left with 2 y's on the bottom. So I just rewrite it as this. So this becomes y squared. Okay, something as simple as that can be simplified to a really easy form. Okay. Alright, now let's take a look at this one. Now what I like to do is I like to factor right above it. It just saves me some workspace and everything. So x squared plus 8x plus 16 is a perfect square polynomial, or perfect square trinomial. Jeez. And so that's just 4x squared. Now for those of you guys at home that have trouble seeing that, I'm going to write out x plus 4 twice, just so we are not missing any one at all. Okay, and then on the bottom, what two numbers multiply to negative 24 but add up to negative 2? Okay, let me see. It's not 3 and 8, 6 and 4. There we go. Okay, so x minus 6 and x plus 4. If you're having a hard time seeing that, pause the video and go try it out. Okay, now if you notice, okay, here's the trick when you're simplifying, and Purple Math has a wonderful tutorial on this. And when you're simplifying rational expressions, you can't just start canceling out x's with x's and all this stuff. You can when you're just dealing with monomials. This is okay. Okay, however, here we will be simplifying parentheses, like parentheses, and I'm seeing that those two are the same. Or you could pick the other one. It's the same thing. Okay. Alright, now what I have left up top is an x plus 4, and what I have left on the bottom is an x minus 6. And you need to understand that x cannot be, and that alt code I still don't have, cannot be negative 4. Space, negative 4. There we go. Okay, and the reason why is that's a removable discontinuity. So you need to understand, you need to be able to state that at the end. Now obviously also people are going to also say, well, x cannot be 6. Well, no kidding. Okay, you can already see that on the bottom. But I want you to know that you don't need to say that. You just need to be able to say the restriction on the variables besides the obvious ones. Okay. Alright, now there is a little trick in math. For example, if you have like something like 3 minus x, and you wanted something and you wanted to factor it out and be able to get x minus 3, all you do is factor out a negative 1. Okay, so this becomes x minus 3, and that's something beautiful I can do. The reason why I show you that is on the next step, I don't like having 12 minus x squared. I like having a negative 1. I factor out a negative 1, and I'm left with x squared plus x minus 12. And that's the beautiful thing about that. Okay, now when I factor it, I'm still going to have that negative 1 there, but now I'm going to have x plus 4, x minus 3, okay, up top. And on the bottom, underneath it, I'm going to have, let me see, what two numbers multiply to positive 15 but add up to negative 8? That would be negative 3 and negative 5, or minus 5. Okay? Alright, so remember, I keep going until I get to these top two ports, and then I start simplifying. Now, if you notice, there's 2x minus 3, so I can simplify those. Those are my removable discontinuities. And so I'm left with negative 1 times x plus 4, okay, over x minus 5. Okay, now it depends on what your teacher's asking, but you can go ahead and distribute the negative 1. Honestly, I'm totally okay if you leave with it in the factored form, because in calculus, this is what we're going to need. So when you factor, don't redistribute and do all that stuff. In my opinion, I don't like it. I'm not a fan of it. I like to see all the factors in as they are. All right, however, you do need to state your removable discontinuity, and x cannot be 3. There we go. Okay, as long as we got that, we're good. Now, let's move on to multiplication and everything. Now, this is where I like to call cross-simplifying, okay, and just seeing all kinds of stuff that I can cross out just by going diagonal, okay? All right, so there's two ways to do this. You can multiply straight across and then simplify. I like to simplify as is. So I like to go ahead and do this. Let me see. Let me see. 2 goes into 1 and 10, 1 and 5 times, and then 5 and 5 both go in each other, so that's 1, so I'm just left with the 4 on the bottom. So that's kind of nice. I'm actually done with the numbers, so that's good. Okay, now the x to the 4th and x to the 3rd, there's 3 x's there. Only one more x left up top, so I'm going to go ahead and rewrite that. Voila. Okay, and then y to the negative 2nd and y to the 3rd. All right, now simplifying this one's not going to be as easy, so you're going to have to do the exponent rule of division, which is subtraction. So 3 minus negative 2 is going to be positive 5. So I would rewrite that as y to the 5th. Okay. However, because we had a removable discontinuity happen down here, x cannot be 0, and that's from our horizontal, nope, I'm sorry, our vertical asymptotes rule. Okay. All right. So on this one, I'm going to do some greatest common factors. So this is going to turn into, I'm going to factor out a 2. So this is going to be 2 times x plus 6. Okay. This one down below, I'm going to factor out a 3. So this becomes 3 times x minus 3. Okay, so that's pretty nice. Now this one, I'm going to factor out not only a 2, but a negative 2, because I want to reverse this. So if I factor out a negative 2, I'm going to have x minus 3, which is a really nice thing. And this one I can't factor, so I'm going to leave as is. Okay. All right, now I look for some common threads here. Now you cannot divide the 3's, you cannot cancel the 2's, so don't try when they're across from each other. But I can simplify the x minus 3's, okay, that I'm left with. And up top, I could just multiply straight across. So negative 4 times x plus 6, I'd say just leave it as is. And on the bottom, I would have 3 times 3x plus 8. Okay. And I would also say x cannot be, the removable discontinuity is 3. X cannot be 3. Now, if you're wondering what else it cannot be, and you're looking here and you're like going, I need to do it, set this up equal to 0, and you'll find out that x cannot be negative 8 thirds. Okay, something simple as that. Alright, now this one we are going to have to just straight up go ahead and factor. So I'm going to take some time and factor it, and then when I come back you'll actually see it factor. Okay, so everything's now factored and I can start cross-canceling stuff. Now, unbeknownst to a lot of people, this looks like a minus sign. I accidentally drew a line that looks like a minus sign. That's times. I'm still going to be timesing. Okay, so I'm going to look for some stuff that can't to simplify. So x minus 2s definitely simplify. The x plus 2s as well. The x minus 3s. Oh, that's pretty nice. Oh my goodness, look at this. Okay. Oof. What am I left with here? Well, if there's nothing up top, there's a 1. If there's nothing on the bottom, there's a 1. Okay? Alright, so when that happens, when you do a removable discontinuities on pretty much everything, yes, your graph is going to look like y equals 1. Okay, or your graph will be like this. Okay, but you have to say your removable discontinuities. So x cannot be, what was it, 2, negative 2, 3, negative 1. Okay? Alright, as long as you understand that, you should be good when graphing this and stuff. And yes, you would graph this as y equals 1, and you would have holes at these 4 spots. Okay? Alright. Let's go ahead and go to the next side. Alright, now division. Now some of you guys have already learned a method called skip, flip, and multiply. And yes, you can still use that, but because of what everyone's pushing nowadays, they want to use the correct terminology. So I always tell my students you cannot divide two fractions, but you can multiply by the reciprocal. So the first part is still going to stay the same. I'm going to write it in factored form just because that's easier. So this would be y minus 3, y minus 2. Okay, and the bottom part's just going to still be y cubed. So that's pretty simple. Okay, now this part I'm going to factor. First, it's going to be y plus 5 and y minus 2. Okay, but when I flip it, I'm going to have the y to the 4th up here, and I'm going to have the y plus 5, y minus 2 down here. And then I can start simplifying by going across from each other. Okay, so the y minus 2's cancel out. Not cancel, they turn into 1's. That probably is better explained over here. The reason why these turn into 1's is because I'm left with a bunch of 1's because everything turns into a 1. So please understand that you're not canceling, you're actually simplifying to a bunch of 1's. Okay, so back to here. Also, right here I have 3 y's down here. Those will simplify with all these y's up here except for 1. So I'm just left with the y up top. And so I'm left with y times y minus 3. And on the bottom I have y plus 5. I can't spend too much time on this one, but if your community is building a park and it wants to fence in the area, it wants to maximize the area for the given amount of fencing, and which shape provides a more efficient use of fencing, a square or circle? Okay, so what you do is you find the areas or the formulas for area and perimeter, and then you solve for S in perimeter, so S equals P over 4. So when you divide the area by the perimeter, okay, it's S squared over 4, or S squared over P. You're going to replace S with P over 4. Okay. Now with circle, area is going to be pi r squared. Perimeter, which is the circumference, is 2 pi r. So you solve for r, and r equals P divided by 2 pi. Okay. So area divided by perimeter is going to be pi r squared over P, and we replace r with P divided by 2 pi. Okay, and we're going to square that. Now when we get done simplifying everything, this is going to be P squared over 16 divided by P. So we're going to times it by 1 over P, which just gets us P over 16. Okay, and this one, I'm going to multiply this as well. Okay, so this is P squared over 4 pi squared. Okay, the pi's cancel each other out, and I'm left with the 4 on the bottom and the p squared on top, and I divide it and I get this. Now If I check out, these two have the same numerator, so they're denominators. This one's bigger. The circle's a more efficient way. Okay, you guys have a wonderful day, and I'll talk to you later. Bye.